At the end of the lesson, the learner is able to apply basic properties of logarithms and solve problems involving logarithmic equation. Lesson outline. Number 1. Basic properties of logarithms. Number 2. Simplifying logarithmic expression. Definition. Let b and x be real numbers such as b greater than 0 and b is not equal to 1. The basic properties of logarithms are as follows. Number 1, log b1 equals 0. Number 2, log b bx equals x. Number 3, if x greater than 0, then example number 1. Use the basic properties of logarithms to find the volume of the following logarithm expression. Letter A, log 10. Number 2, natural logarithmic expression of 3. C, log 4 64. Letter D, log 5 of 1 over 125. Letter E, 5 log 5 2. Letter F, log 1. Solution. The log 10 is equal to log, and for our example number 1, the solution of or the value of the following logarithmic expression is here. In letter A, log 10 is equal to log 10 with a base of 10 raised to the power of 1 equals 1, and this is property 2. And letter B, natural logarithmic expression 3 is equals to log 3 with base of e to the power of 3 equals 3. And that is property 2. Letter C, log 46 with a base of 4 equals log I mean log 4 with a base of 64 equals log 4 with a base of 4 raised to the power of 3 equals 3, which is also property 2. And then for letter D, log 5 of 1 over 125 equals log 5 with a base of 5 raised to the power of negative 3 equals negative 3, which is property 2 also. Letter E, 5 log 5 with a base of 2 is equals to, and this is property 3. For F, log 1 is equals to 0, and it is property 1. And now we will move to example number 2. Example number 2, suppose you have seats to a concert featuring your favorite musical artist. Calculate the approximate decibel level associated in a typical concert. Sound's intensity is 10 raised to the power of 2 with m to the power of 2. Refer to lesson 17 for a discussion sound intensity solution. So these are our solution. D equals 10 log of 1 over 10, and then we will make it D equals 10 log 10 minus 2 over 10 minus 12, and then bring down, or we will move to the next solution, that D equals 10 log of 10 raised to the power of 10. D equals 10 times 10 property 2, and that is D is equals to 100 dB. Answer A concert decibel level is 100 dB.
Example 3. Calculate the hydrogen ion concentration of vinegar that has a pH level of 3.0. Solution: pH plus minus log H plus 3.0 equals minus log H plus negative 3.0 equals log H plus 10 by the power of 3.0 equals 10 log H plus 10 by the power of 3.0 equals H plus property 3. The correct answer is that the hydrogen ion concentration of vinegar with a pH level of 3.0 is 10 by the power of negative 3.0 moles per liter. Because we can use the equation pH is equal to negative log H plus, where H plus represents the concentration of hydrogen ions. By rearranging the equation, we can solve for H plus. pH is equal to minus log H plus, 3.0 is equal to minus log H plus, negative 3.0 is equal to log H plus. Now we can use the logarithmic property that states 10 log x is equal to x. Applying this property, we can find the value of H plus. 10 by the power of negative 3.0 is equal to 10 log H plus. 10 by the power of negative 3.0 is equal to H plus. Therefore, the hydrogen ion concentration of vinegar with a pH level of 3.0 is 10 by the power of negative 3.0 moles per liter. Solve examples. Use the basic properties of logarithms to find the values of the following logarithmic expressions. A. Log 7. B. E by the power of in 5. C. Log 10 by the power of x squared. D. Log 1. 3 in e by the power of x plus 1. F log 7 times 1 over 49. Solution. Solution A log 7. This expression represents the logarithm of 7 to the base 7. In other words, it asks the question, what power must 7 be raised to in order to obtain 7? The answer is 1 because any number raised to the power of 1 is equal to the number itself. Therefore, log 7 is equal to 7. The answer is 1 because any number raised to the power of 1 is equal to the number itself. Therefore, log 7 is equal to 7. B. E by the power of in 5. In this expression, we have the natural logarithm in of 5. The natural logarithm is the inverse function of the natural exponential function, e by the power of x. So, in 5 represents mathematical constant e, approximately 2.71828 must be raised to obtain 5. Therefore, e by the power of in 5 simplifies to 5. C. Log 10 by the power of x squared. This expression involves a logarithm of a power. The logarithm of a number raised to a certain power can be simplified using a logarithmic property. log A by the power of B is equal to B log A. Applying this property, we have log 10 by the power of x squared is equal to x squared log 10. Since the logarithm of 10 is 1, we can further simplify the expression to x squared. The log 1, this expression represents the logarithm of 1 to the base 3. The logarithm of 1 to any positive base is always 0 because any positive number raised to the power of 0 is equal to 1. Therefore, log base 3, 1 is equal to 0. Number I. E by the power of x plus 1 because we have the natural logarithm in of e raised to the power of x plus 1. The natural logarithm is the inverse function of the natural exponential function e by the power of x. So e by the power of x plus 1 represents the exponent to which the mathematical constant e must be raised. F log base 7 times 1 over 49. This expression involves the logarithm of the reciprocal of a number. According to the basic property of logarithms, the logarithm of the reciprocal of a number is equal to the negative of the logarithm of the number. Therefore, log base 7 times 1 over 49 is equal to negative 2. Number 2, calculate the sound intensity in watts meter per squared of a 65 decibel sound. The formula for sound intensity in decibels, D is equal to 10 log I over I base 0, where I is the sound intensity in watts per square meter and I base 0 is the reference intensity. Usually 10 by the power of 12 watts per square meter. We are given that D is equal to 65 decibels. Plugging this into the formula, we get 65 per is equal to 10 log I over 10 by the power of 12, negative 12. To solve for I, we can isolate the logarithm term taking the logarithm base 10 of both sides. Therefore, the sound intensity of a 65 decibel sound is approximately 3.16 times 10 by the power of 6 watts per square meter.